Hi guys, welcome to 12.5 Compound Events. If you toss a coin and roll a number cube, the events are independent. The outcome of one event does not affect the outcome of the second. So if you have a coin and you flip it, then you have a dice and you roll it, what you get for your coin doesn't influence what you might roll with your dice. So they're independent. Each one happens independent of each other. Find the probability of tossing a heads, so you flip your coin and getting a heads, and rolling an even number on your dice. So how do we solve for two things happening independently of each other? So then our question says, find the probability, P, probability, in parentheses, H and E, probability of heads and an even roll. Heads and E, even, are independent. So step one is we're going to find the probability of flipping a heads. Well, remember, probability is favorable outcomes over total number of outcomes. So between heads and tails, we want heads, so there's only one favorable outcome. But what are our total numbers of outcomes? Well, heads and tails, 2. There are 2 total number of outcomes. So it becomes a 1 over 2. Now, independently again, we're going to find the probability of rolling an even number. So here we have the probability of flipping heads. Now start over. What's the probability of rolling an even number on a number cube? That's 1 through 6. Well, between 1 and 6, there are 3 even numbers. So the probability, or the number of favorable outcomes, is 3, because you can do a 2, a 4, or a 6, over top of your total favorable, or not total favorable, your total options available to you. On a number cube, there are 6 total options available to you. So your 3 favorable over your total, which is 6. So 3 over 6 is equal to 1/2. Step 3 is taking your 2 independent events and putting it together. So we have 1/2, or the probability of 1 over 2 for flipping a heads. Then we have the probability of 1 over 2 for rolling an even number. But now we have to do, what is the probability of flipping a heads and rolling an even? Well, we multiply our 2 probabilities together. So the probability of flipping a head is 1/2 times the probability of rolling an even, which is 1/2. So 1/2 times 1/2 is equal to 1/4. So you have a 1/4 chance of flipping a heads and rolling an even number, or 25% chance. And again, that's called independent probability, where one event does not influence the outcome of the other. But what happens if you have an event where one influences the second? That's called dependent. If the outcome of the first event affects the outcome of the second event, the events are called dependent. And now here's the example that they give. A bag contains 3 blue and 3 red marbles. Draw a marble, meaning literally draw a marble out of the bag, not to draw a marble. So draw a marble out of a bag, then draw a second marble out of the bag. Without replacing the first marble, find the probability of drawing 2 blue marbles. So we're talking about a sequence of events. Here is a bag of marbles, and again, they said I have 3 blue, 3 red. So I'm going to draw 1 marble out of the bag, put it down right here, and now I'm going to draw a second marble out, put my second marble down next to my first. I didn't put my first one back in the bag. I didn't restore my total number of marbles. My first time, I had 6 marbles from my 3 blue and my 3 red. I pulled a marble out, so now I'm 1 less in my bag. I only have 5. So my less marble in my bag is going to influence the likelihood of what color I pull out on my second attempt. So let's look at that. Find the probability of drawing 2 blue marbles without putting any marbles back. Step 1, find the probability of drawing a blue marble. Well, from the very beginning, I had 3 blue marbles out of 6 total marbles. 3 over 6 is 1/2. Second, I need to find the probability of drawing a blue marble after I've already pulled out a blue marble. So, how many blue marbles are left in the bag? Well, if I originally had 3 and I pulled out 1, now I have 2 blue left. If I originally had 6 marbles, but I've already pulled out a marble as well, now I only have 5 marbles. So find the probability means we need to multiply. What was the probability of drawing blue? It was 1/2. What's the probability of drawing a blue after we've already pulled one blue out? 2/5. Multiply it together. 1 times 2 is 2. 2 times 5 is 10. 2/10 reduces to 1/6. I mean, not 1/6, 1/5. All right, let's work through some of these example problems together. In exercises 1 through 6, you draw a marble at random from a bag of marbles shown. Then you replace it, draw again. Find the probability. So step 1 is I'm just going to count my total number of marbles. I only have blue and red again. Trying to get my marker to click, which it does not want to do. Okay, oh well. How many marbles do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 total marbles. And now it says, again, you draw a bag at random, or marble at random, then you replace it, draw again. So what's the probability of drawing a blue marble? Well, how many blue do I have? 1, 2, 3, 4. I have 4 blue marbles, so step 1, an independent events, so I draw one, put it back. I need to find the probability of the first one. So what's the probability of blue? Probability of blue is 4 out of 10. And then what's the probability of drawing red? 1, 2, 3, 4, 5, 6. It's going to be 6 out of 10. So probability of blue was 4 out of 10. Probability of red was 6 out of 10. And now I multiply them together, so you can choose to reduce it first or reduce it second. I'm going to go ahead and reduce it, so I have 2/5 times, divide by 2, 3/5. And I'm going to get 6 out of 25. The chances of drawing a blue and a red is going to be 6 out of 25. Now, what's the probability of drawing 2 reds in a row? Well, remember, I'm drawing a marble and putting it back this time. So what was the probability of drawing a red before? Again, count them up. 1, 2, 3, 4, 5, 6. Probability of drawing a red is 6. Reduce it, divide it by 2, and I'm going to get 3/5. And now I'm going to repeat it again. Because I put that marble back, probability of drawing 1 red is going to be 3/5. Probability of drawing a second red marble is still going to be 3/5 because I put the marbles back. And now I'm going to have 9/25 as my total probability. Last, 2 blues. Well, we counted out that I had 4 blues. So 4 out of 10, which is going to be just 2/5. So the probability of drawing 1 blue is 2 out of 5. What's the chance of drawing a second blue after I put that original marble back? It's going to be the exact same. 2 out of 5. 2 times 2 is 4. 5 times 5 is 25. So I have a 4 out of 25 chance of drawing 2 blues in a row. Next it says, next you draw 2 marbles randomly without replacing the first marble. Find the probability. So here, this is that exact situation where it is dependent. My first marble draw, I'm going to have every option available to me. I'll have my total amount of marbles. But I'm going to take one out for my second draw because I'm not replacing my original marble. So my marble count's going to be down. So what does that mean for this problem? That means for all of my first draws, I'm going to have 10 marbles to choose from. But on my second draw, I'm only going to have 9 because I didn't put my marble back. And then I just need to be careful of how that might influence it. So for example, probability of drawing a blue marble and a red marble. So what's the probability of drawing a blue marble? Well, again, it's 4 out of 10, right? Or 2/5. My probability of drawing a blue marble, which we've already established multiple times over, is 2/5. I'm going to leave it as 4/10 actually. I'm not going to reduce it right now. Is 4/10. And that is just to draw blue. Now they said, what's the probability of drawing red on my next one? Well, I pulled out a blue, so I still have the same amount of reds as I've always had. So because one blue is gone, my same amount of red's still there. So I always had 6 reds. So my numerator is still 6. But what's my denominator now? Because I pulled out one blue. So instead of 10, I have 9. So now just multiply it. 4 times 6 is 24. And I have 24 over 90. And again, you want to reduce it. You can reduce that by 3, pull out a 3. You can keep going after that. But for right now, I'm going to go ahead and keep going for the sake of time. But you definitely want to reduce problems like this. All right. Next, we have what is the probability of pulling 2 reds? And this is the exact same as our first example. So what's the probability of drawing 2 reds? Well, step 1, what's the probability of drawing 1 red? Probability of drawing 1 red is 6 out of 10. But now, what's the probability of drawing a second red? Well, we've already taken 1 red out of the bag, right? Our first draw was what's the probability of pulling out 1 red, and it's 6 out of 10. So we've taken a red out of the bag. Well, probability again is favorable outcomes over total number of outcomes. If 1 red bag has already left the bag, that means I only have 5 favorable outcomes left over my total number of outcomes. Well, I've already pulled one of my total outcomes out of the bag when I pulled out that first red. So instead of 10, I have 9. 6 times 5 is 30. And now 9 times 10 is 90. That reduces easily to 1/3. I have a 1/3 chance of pulling 2 reds out of the bag right away. We're going to repeat that same process for number 6 for pulling 2 blues. Well, what was the probability on our first go around of pulling out a blue? 4 out of 10. So we have a 4 out of 10 chance of pulling a blue out of the bag. We're going to assume that's successful. And so now what is the chance of pulling a blue after we've already pulled out a blue? Well, if we've already pulled out a blue, what's our total amount of favorable options? Instead of 4, we now only have 3. And because we're down 1 marble, our total is not 10 anymore, it's 9. 4 times 3 is 12. 10 times 9 is 90. And again, you would want to reduce that, but for the sake of time, we're going to keep going. But even as simple as pulling out a 3, if we pull out a 3 from both, we'd get 4 over 30, 2 over 15. Easy enough. All right, let's keep going. You draw 2 letters randomly out of a box containing the letters M-I-S-S-O-U-R-I, so Missouri. Number 7. Suppose you do not replace the first letter before drawing the second letter. What's the probability of first drawing an M, then an I? So we're back to dependent. We pull out an M and we do not put the marble back or the letter piece back. And so with a smaller denominator, what's the chances of next pulling out an I? Well, first, what are the favorable chances of pulling out an M? How many favorable chances do we have? Looking at the word Missouri, we only have 1 M out of how many possible options? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 options. So that's the probability of our first event, is 1 out of 8. Now, what's the probability of drawing an I? I'm going to put my multiplication symbol there because I know I'm going to multiply. Well, how many I's do I have? 1, 2. I have 2 favorable chances of pulling out an I. But now, what's my denominator? I've already pulled out my M, and it's no longer in the bag, so I'm down 1 on my denominator. I originally had 8. Now I have 7. 1 times 2 is 2. 8 times 7 is 56. And then 2 goes into 56. I'm having a brain fart. When in doubt, multiply it out, right? 1, 6, 28 times. There we go. So we have a 1 in 28 chances of first pulling an M and then second right after it pulling an I. Boom. Number 8. Suppose you do replace the first letter before drawing the second. What is the probability of drawing an M than an I? Take a second and guess. Do you think you'll have a greater chance or a lesser chance of pulling your sequence in this particular order? Guess, 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 guess. All right, let's check. So what's the probability of pulling an M? Well, we already said that was 1 over 8. Well, now what's the probability of drawing an I if we put that M back in the bag? Well, we still have 2 I's. So our number of favorable outcome is still 2. But now what's our denominator? We put the M back in, so we're back to 1, 2, 3, 4, 5, 6, 7, 8. 1 times 2 is 2, 8 times 8 is 64. Reduce it. Now we have a 1 in 42, that's a 60, a 1 in 32 chance of getting it correct. So by putting that M back in the bag, we lessened our chance of being able to pull the tile we wanted out right away. All right, guys, I hope that made sense. You can go ahead and start your homework. And again, for these ones, don't forget to reduce. I just didn't to save time, but you definitely do want to reduce all of these. All right, have a good day.